So to introduce Dave, Dave is a director at AECOM. He specialises in sustainability and regenerative design in the built environment. He has written Building Revolutions, the handbook to building a circular economy, and most recently, Regenerative by Design, a book that explains how buildings can have a positive impact on the planet and become part of an active ecosystem. So Dave, without any further ado, would you like to take it away?
Brilliant, thank you. Wow, you've basically just stolen my main line there, so I can make this very short now. But thank you, that's great. Thanks for a nice intro, and thank you very much for inviting me. It's really exciting to talk about this, and it's particularly interesting to be talking to you that are covering I think coming from quite a different angle, because a lot of the time I'm talking to people who are building buildings rather than the bigger stuff, and I think the two are so interconnected, and I'm generally explaining to people what we need to be thinking about from an infrastructure and major projects perspective to people who are focusing mainly on the individual buildings. So I think it'd be a very interesting discussion. And this is just we did a visualization of what it might be like to open up the Fleet River in London that's completely underground. Outside, this is outside King's Cross here, but it all goes all the way down to follows the Farringdon Road and goes all the way down into the Thames underground. So yeah, I mean, I think you know all this, but just briefly, it's really, this is the view from our office in Aldgate. You can see that a lot of the cities are really just steel, concrete, glass and tarmac, and very little space for anything green. There's a couple of trees down here and that's about it, and that does two things. Firstly, it doesn't give us much space. It doesn't give the natural world much space. But the other thing is it for us city dwellers, or a lot of city dwellers, it's very easy to forget that we have this very intimate and total dependence on healthy ecosystems to survive, and that's down to every mouthful of food, every sip of water, and even every breath that we're hopefully just going to take in a second. And without that, we don't, without that ecosystem, we don't have the ability to it's basically our life support system. And I think what's really interesting is that our cities and towns and our buildings are remarkable feats of engineering and architecture, but actually and also a very effective way of accommodating a huge amount of people in a very small space. They are actually very efficient in area of land, if you look at it across the globe. However, as you all know, there's this huge amount of infrastructure that we all take very much for granted. From my side of things, when a developer and architects are building a new building, we take all this stuff for granted, that it's all going to be there. We're going to get low carbon electricity from the a super low grid. We're going to get all our water just given to us with the duty to connect and everything else. All the waste water is going to be treated. We don't have to worry about any of that. All of the, my previous book writing about circular economy, that all the materials and resources that we need to build our buildings is just going to be there at a click of a button. And even things, what seems slightly outside of the world, our world, but it's still very important things like, the food production and everything. We flying and shipping stuff in from southern Spain. And I don't know about you, but I get all my get fruit and all this sort of stuff, and lettuce and everything, and then half the time I find it in the bottom of the fridge a week later, and it's all gone a bit mouldy, and it's been flown in, some of it a great privilege to me to using huge amounts of water and energy to do that. So it's all a bit crazy, isn't it, what we set up? So I think these are this is all really key to it, to show actually the footprint of our cities isn't the footprint of the city. It's much wider than that, and all of this land take and resource take is huge. And actually, I really like, I'm sure you know this, but the Stockholm Resilience Centre, I really like this summary where you've got this safe operating space in the green area here, and how we've just transgressed all of these limits already. And I think the latest updates it's getting even worse. I won't go through all of these because you know these, but just a couple down the bottom to explain. So that's phosphorus and nitrates. So that's all the stuff going into coming out of sewage, out of chicken farming, and all this stuff that's going onto our land and then making its way into the rivers. And then novel entities is if you're having a drink right now, then you'll be drinking microplastics. I saw Matt was just having a sip there. So yes, that's just entering our bloodstreams and getting into our bodies, into our cells. So there's no escape from this stuff. And of course, there's forever chemicals and everything else. So there's lots of issues here that we know that are happening. So I mean, I spent the last 30 years really of my career talking about sustainability, trying to get buildings to be a little bit less bad. And I think that's the key. Is it's a good phrase that I think, say can we use a little bit less energy, a little bit less water, a little bit less materials, generate a little bit less waste when we're building these things and operating them. But actually, it's really clear now that to me that isn't enough. And actually, what we really need to be doing is moving, through this graph, through the sort of neutral zero impact, through to something where we can maybe start to restore and regenerate the natural environment and start to be more net positive. And I know that sounds like a real pipe dream and real crazy, but there are some case studies I've got. I'll show you where we're starting to do that, or it's starting to happen around the world. And I think it's so important, that if we can start to demonstrate that we're actually actively restore things, and as the intro, we said in the intro that that we're actually, as Janet was saying, can we make our built environment an active part of the ecosystem rather than it being something that basically stamps all over it? So in my book, I tried to just summarize the what I was trying to cover. So I start with this and it builds up. But the idea is that certainly from my perspective, and a lot of the projects I work on, the site is the red line boundary, and you don't really think beyond that. And I know it's different from you, and I think that's why it'd be really interesting to discuss today. But actually, it's so obvious and clear, really, when you look at it, that actually, of course, the red line boundary is just this artificial line we've drawn. The site is nested within locality, it's nested within the city or the region, and ultimately it's nested within the ecosystem. And it's, we are bound by the planetary limits that is this little blue marble flying through space. And that's all we've got. We've got no ability to go beyond that. And we're already very much in debt. So, one of the key things, I think the sort of 3 key points out of this is out of these design principles. I was trying to bring regenerative design as an idea and a concept down to something that was slightly more tangible. It's not all the way down yet, because I think there's a lot more work to do, but trying to say, right, what do we mean by regenerative design? And these are, I felt from my research, these felt the sort of key design principles to be looking at. So just pick up 3 of those, because I think the others are fairly obvious, but the sort of 2 big revelations for me were ecosystem services and designing with environmental budgets. Systems thinking I'll also mention as well, but I think those were the sort of things that really made me think. And again, it's probably something that you know a lot more about, but from the building side, nobody ever talks about ecosystem services. It just isn't mentioned. And I, sitting near my infrastructure colleagues, I hear that phrase used a lot more. And we've got a whole, natural capital team who look at ecosystem services. So it's really interesting that there's a researcher, Maybright Pedersen-Zari, based in New Zealand, who did a lot of work on this, looking at, can we take all of these ecosystem services and then see how many of them can we apply and mimic in the built environment. And the ones you can see, the sort of ones that are here, things it does. Obviously, the ecosystem is doing all these brilliant things for us, regulating the climate. It's managing the nutrient cycling, which we're busy distorting and twisting in all sorts of directions. It regulates hydrological flows, and this is a massive issue, isn't it? Because we're having to draw so much water out of the system and surround it by concrete and pipe it to people, and then deal with the waste out the other end of it, whereas actually in nature everything has been slowed down, retained, and we speeded everything up hugely. And of course, things like purification of air, water and soil, absolutely essential things. And these other things are fairly obvious. So can we do that in the built environment? Well, I mean, I'm sure you are on some of your infrastructure works on the bigger projects. On the buildings, I found this is a great case study, I think, of the Google HQ in San Francisco, sitting in the bay there. And what they've done is they were required, when they were building here, they were told that they couldn't let any fresh water runoff from the hard standings go onto outside the site, because this is all salt marsh and it's all protected habitat. And if you start letting fresh water run off, in large quantities go into that, you actually dilute the salt water and actually damage the habitat. So what they've done is they built these retention ponds. They've got a this square building here is the water treatment works, which treats grey and even black water and recirculates what they get out from the black water back onto to flush the toilets. So pretty radical stuff for a building project. And of course, you've created a natural environment here which is doing all of these other things. It's helping to purify air, water and soil. It's created a really nice environment for the people there, the Googlers, to be wandering around. So it's working really well. They're also, by the way, they happen to be generating massive amounts of their energy. Every one of those panels on this roof is a photovoltaic panel. So these are generating around 40% of the energy. Got ground source and all sorts of other things going on. So really, that first one was really this, and it's quite a bit of a head tingling moment for me when I thought, this is what I've been looking for. This idea of can we look at ecosystem services? Because the other thing with ecosystem services, of course, is we can actually quantify them. And a lot of people railed against me when I said, well, we need to quantify stuff and get some numbers for this, and saying, well, that's what it's all about, getting the right concept. So yes, but we know how the world works. You've got to get stuff in the brief, you've got to get the targets in there, and you've got to be able to measure stuff. So you can do that. And I think the other one, which is also quantifiable, is actually this idea of designing with environmental budgets. And typically in buildings at the moment, what we do is we try and reduce the demand for energy as much as we can to some sort of made up number that we've come up with. Whereas this was really twisting it on its head and saying, okay, how much energy is falling on the site from the sun, from how much is available underground, how much water is falling out of the sky? Okay, work that out. And in lots of parts of the world, we can then say that is our budget. And we're going to design within that. And that's what they did here on the PAE Living building in Portland, in the Pacific Northwest in America. Is they said, look, we can cover the whole roof in photovoltaics. We've also got a building up the road, affordable homes building up the road, which we can put some photovoltaics on and pay for that for them. And that is our budget. And then they were very careful to design within that budget. So this building is actually net positive. So it generates more energy than it needs across the year. And similarly with the water, they worked out how much rainwater they could capture, and they capture and treat all of that rainwater on site. And they again are net positive in water use as well. They have got 3 systems in the building. So they have the rainwater collection, they have the grey water, and they treat the black water, which is in these composting bins. And then the compost is taken away every sort of couple of years for use as fertilizer. And what was really interesting, I thought, is where the whole systems thinking comes in, as well as this idea that you then become not only not a burden on the infrastructure, you actually become a net positive provider, but also they are reclaiming all the phosphorus and the nitrates out of the wastewater, and they reckon they get about $50,000 worth of fertilizer out of that. So there's actually a revenue stream coming out of treating, capturing this, which I know happens at the sewage treatment works, but not I don't think not as effectively. So you can actually take it at the source when it's in its purest and capture what would have gone down to the sewers. The other thing to mention here is they did some work with the local water authority, who initially said, no way, you can't take rainwater and turn it into potable water. You've got to connect to the mains. Just take it on the head, take it on the chin. That's the way it's going to work. But actually, they negotiated with them and they said, look, okay. And in the end, what they did is they got them to license, or the water authority agreed to license every surface that the rainwater fell on, and also the treatment they put in place to get it to potable standards. So it is actually can be possible with negotiation rather than conflict. And that sort of that systems thinking is, I think, really key to all of this. And that idea of the phosphates and the nitrates shows an example of where, you know, that bigger system that we've got, where we're busy mining for phosphates, we're got whole factories capturing, you know, fixing nitrogen out of the air so that we can make fertilizer, which then goes on the land, most of which then gets washed out into our rivers and pollutes the rivers. Whereas we could be capturing all of the, you know, doing these things and making some of these circles a lot smaller and a lot more localized. And the same goes for things like urban agriculture. So this, I haven't got time to go through all these, but this building is growing its own food in a building integrated greenhouse that is not only integrated architecturally, but it's also actually recirculating the air. So the wet, the moist, humid, CO2 laden air from the offices and the labs then is going into the greenhouse, which of course is perfect for what the plants want, and vice versa. It cleans up the air back again, and it's trying to do the same with water. So it's really interesting how they started to integrate things. But of course, then you've also growing food locally rather than having to ship it in or fly it in from a long way away. Makes it fresher, reminds people of connection with nature and that sort of thing. And the other one I might just mention is the Sponge Cities one, which is, I'm sure you've heard of, but in China they have a requirement to where they've got all these low-lying cities along the Yangtze River, very prone to flooding. They've put in requirements to make a lot more, you know, porous and spongy areas with green areas where they're capturing the water and storing it. It also cleans up the water and purifies it, as well as giving them resilience against climate change. So I won't have time to go through all of those. So that was just a quick snapshot. Just a final slide, which is just looking at this. I think it was a really interesting project where I was trying to find a project that attempted something on all of these. Most of the project case studies I've got in my book are really just picking up one or two and not able to do the other areas. But this one's probably the closest. And this was in Amsterdam, and this was set up by the community, and you know, just a couple of people said, hey, why don't we've got a real problem here. The land is very expensive in Amsterdam, and in the back of everyone's heads in generally in the Netherlands, I think, is this sort of worry about sea level rise that they're so vulnerable to. And of course, you know, we are in London, I guess, as well, and other parts of the world, and many other parts of the world. But it's very much sort of front of mind to people living in Amsterdam. And so they put out a request and said, does anyone else want to join us in creating a floating community? They sent it out to friends and friends of friends, and they got so many responses they had to close. They closed that down the list very, very quickly because it was such a popular idea. It's self-funded. The developer's not in the loop, so they take their whatever it is 10-15% margin that would have gone to a developer, and they've used that to pay for and the self-funding to pay for the smart jetty that you've got here. It is all. It's got a microgrid, so it's all interconnected. Some buildings are generating energy, some buildings are using it, so it shares the energy between the buildings before it then connects and exports or imports from the grid. They're reclaiming reclaiming heat out of the water with heat pumps, and they're doing all sorts of really cool stuff. Lots of careful thought about materials and everything, and of course there's the whole resilience built in as well, and they've created habitats for wading birds and things as well. So they're doing lots of really cool stuff. And one I thought was really interesting, and I've very rarely seen this, is on their website they list out all the things that went wrong and the lessons they learned. And I thought, wow, wouldn't it be great to do that? I don't think we've ever been able to do that. I don't think the project I've ever worked on, it's always been, it was great, it went really well. But they said, well, this didn't work very well, so you might not want to do that again. For example, said they were going to filter all the they put showers in that filter the water, recirculate the water, so 90% of the water is reused in the shower through a filtering system. But they said that actually caused problems with the residents who had to do a lot of work, doing the cleaning the filters and all that sort of stuff. So they said next time they would probably look at that at a different scale. So they'd probably do that at the whole community level rather than doing it at individual building level. And I think that I didn't really mention that, but I think that's one of the other things that's really key about this whole regenerative design thing, is looking at the appropriate scale for things. So some things might be at a building level, community level, some things at the regional level, and some things still stay at the national level. And I think what we're going to have to do is start to do more of a hybrid approach, like we have done for energy, where we're looking at local area networks and heat energy grids and local energy grids and that sort of stuff, and heat reclaim and heat sharing and district energy and things. And I think we're going to have to start thinking about the same for things like water and other key things that we're doing. So that's it. That's my book, and this idea that we are integrally. I'll just leave with this thought that we are we're completely dependent and synergistic with the ecosystem. So really, we ideally want to be working with it. Thank you.